Hello, in this video we are going to see how we can use the basics of the method of elimination to learn the method of row reduction in augmented matrices. We want to solve the following linear system of two equations and two unknowns. So we have 3x plus y is equal to 8 and x minus y is equal to 4. In the method of elimination, what we try to do is to eliminate one of the variables to be then be left then with one equation that has only one of the variables, and we can find the value of that one. We are going to review what are the things that we can do in this case. I will begin by saying that I'm well aware that one solution could be just to sum the two equations and then we eliminate the y, but then we won't review all the things that we are able to do, and that's what I exactly want to do. Let's call our equations, well, then we have equation 1 and equation 2, but let's talk about them as rows, row 1, row 2. So the first thing I want to do is to interchange the rows. So this is one of the legal moves that we can take. We can interchange rows, and that's what I'm going to do over here. I'm going to change row 1 by row 2 and row 2 by row 1. So I can write this as row 1 changes to row 2. So I'll be left with x minus y is equal to 4 in the first row and 3x plus y is equal to 8. Now I'm going to replace the second row by the row itself plus negative 3 times the first row. Let me write what I'm doing over here. So I'm going to write negative 3 multiplying row 1, and that's what I'm going to add to row 2 to obtain my new row 2. This is another one of the legal moves we can take. So let me write it over here. I replace any row by itself plus a multiple of another row. So what do we get in this case? The first one stays the same, x minus y is equal to 4. And then I will write it over here. You don't need to do it always, but I'm going to have negative 3 multiplied by x, and then minus negative 3 multiplied by y, and then negative 3 multiplied by 4. And this is the first row multiplied by negative 3. And I need to sum that to the second row, so 3x plus y is equal to 8. So when I'm summing over here, I have negative 3x times 3x, nothing. So we will write here 0x if we want. And then I have minus negative 3y, so 3y plus y, so that's 4y. Add it here. And then we have negative 3 times 4, that's negative 12, plus 8, so this is negative 4. So these notes I wrote here on the bottom, they are just for myself. You don't need to write that, just to make sure I don't miss anything. Now I'm going to do the third one of the legal moves that we can take. I'm going to replace the second row by a multiple of itself. And the multiple is going to be, well, I'm going to multiply by 1/4. So I get y instead of 4y. I'll write this as 1/4 multiplying R2. And I'm going to write here what it is that we are doing. Replace any row for a multiply of itself. And in this case, we have x minus y is equal to 4 and y is equal to negative 1. Now we're really done solving the system because we know what is the value of y. So we can find what is the value of x. X is, according to the first one of the rows, 4 plus y. So x is equal to 4 minus 1. So I'm saying that x is equal to 3. Then the solution for this system is unique and is of the form 3, negative 1. I made a little bit of a space over here. I want you to look at what we have done and notice that actually We didn't do much about x and y other than writing them many times. If we can keep the coefficients and just make sure that we write always the equations in the order x, y equal number, then we don't need to write x and y on each step. So this is the simplified notation that we are going to use. And it's called augmented matrix. So I will write, instead of writing 3x plus y is equal to 8, I'm going to write 3 for the coefficient of x, 1 for the coefficient of y, then I'm going to put a line instead of the equal, and I'm going to write x on the other side. So the first row of our original system, this system over here, is now written in this simplified form, 3, 1 bar 8. The second row is 1, negative 1, 4 in simplified version, and I say this is called augmented matrix. And all the operations we did, we could have done them writing this simplified notation. And this is what we call the method of row reduction. And we are going to see an example of this in a second. Row reduction. This is our example. I want to solve the system. 2x plus 3y is equal to 4 and 5x plus 4y is equal to 17. In our simplified notation of augmented matrix, I can write 2, 3 bar 4 and 5, 4 bar 17. If you look at the system, there is no obvious move that will give me easily 1 for the value of x, for instance, or eliminate the 2x. So what I'm going to do is to substitute each of the rows by a multiple of itself. I'm going to substitute the first row by negative 5 times itself, and the second row by 2 times itself. By doing this, I'm going to get for the first entries negative 10 and 10 in the first column, and that's going to be very convenient for us to eliminate the values that correspond to x. So when I multiply by negative 5, I'm going to have negative 5 times 2, negative 10, and negative 5 times 3, negative 15, and then after the bar, negative 5 times 4, negative 20. Now I multiply the second row by 2, so I'm going to have 10, 8, and 34. So I can substitute the second row by the first row plus the second one, so R1 plus R2. So I obtain a 0 at the beginning of the second row. So I have negative 10, negative 15, and negative 20 in the first one. And now in the second one, when I sum negative 10 plus 10, I get 0. Negative 15 plus 8, I get negative 7. And negative 20 plus 34, I get 14. For the next step, I'm going to multiply by negative 1 over 7, the second row. So I can achieve having a 1 in the second place, now that I already have a 0 in the first entry of the second row. So the first one stays as we have it. Negative 10, negative 15, negative 20. And now the second row is going to be 0, 1, and negative 2 by multiplying negative 1 over 7 times 14. So the second row is now telling me that y is equal to negative 2. And now that we know what is the value of y, we can go back to any equation we want that has a non-zero coefficient for x and find the value for x. In particular, I will choose to go back to the first original equation we have. So 2x is the same as 4 minus 3 times y, so minus 3 times negative 2. So 2x is equal to 4 plus 6, which means that x is equal to 5. Then the solution for the system we have is 5 and negative 2. And remember, we could check the solution if we wish to do so. And we solve it by the method of row reduction. This method may seem like a little bit of an overkilling for a 2 by 2 system that we could solve in easier ways. But what we are moving towards now is systems where we have 3 equations and 3 unknowns. Ax plus by plus c is equal to d, and then ex plus fy plus g is equal to h, and then ix plus jy plus k is equal to l. So we are going to have 3 equations and 3 unknowns, and we're gonna use the method of row reduction to, once we write this as an augmented matrix, we want to achieve to have a 0 in the first row, in the first entry of the second row, and then 0 in the first and the second entries of the third row. So our system will have this shape that we call echelon form, like a star. And thanks to those zeros that we're going to have in the convenient places, we are going to be able to solve the system.